Okay, so today's topic is what is radioactivity, the difference between alpha, beta, and gamma radioactive decay, isotope, isobars, and isotone concept, the nuclear fusion and nuclear fission, Isodiapher and Isostar, T-Huff, and radioactive decay formula. Okay, so what is radioactivity? Radioactivity is a spontaneous emission of energy from unstable atoms. There are stable atoms which remain in the same forever, and unstable atoms are those which break down and forms the new atoms. So this instability is not happening due to the electronic configuration, but this instability is basically the nuclear instability. That means it's happening inside the nucleus. These unstable atoms are said to be radioactive because they emit the radioactivity from the nucleus as they followed by they have decayed, right? So here I have shown a pictorial representation, and you can see that radioactive decay is happening in the uranium-238. So when uranium-238 gets unstabilized and it forms the alpha particles, and also it decays the gamma radiation and also emits the neutron, proton, and other kind of particles, right? So what is alpha decay? The alpha decay is happening in radioactive 235 elements, and it gives the thorium, and also it emits the alpha particles. Alpha particles is nothing but the helium. And uranium-235, you can see here, it emits the beta radiation, and it calls the beta decay, and it forms the neptunium elements, followed by it emits the beta radiation. What is gamma decay? It emits the uranium-235 and it forms the new element which is called the thorium, and it also removes the gamma decay. The difference between alpha, beta, and gamma radioactive decay. The difference between alpha, beta, and gamma radioactive decay can be summarized as follows. The alpha decay forms the new element with 2 fewer protons and 2 fewer neutrons. The beta decay forms the new element with 1 more protons and 1 fewer neutrons, whereas the gamma decay forms no new element. You have to remember, when gamma decay emits, there is no new elements that comes out, but the element has higher energy released due to gamma decay, because its penetration power is very high. The gamma radiation has highest penetration power, as I mentioned. The beta decay goes to second and alpha decay is last. However, alpha particles also make the most damage, even it has the lowest penetration power among the three. Now the difference between alpha, beta, and gamma radioactive decay. Here I have summarized a nice table. Here you can see the nature. Alpha particle is considered as a helium particles. The beta is considered as the electron, and it has a negative mass. And the gamma radiation is considered as a electromagnetic wave. The charge, you can say here, alpha radiation +2, beta is -1, and the gamma radiation is 0. The mass, the relatively large because it's helium atom, the very small, the beta, and there is no mass in gamma radiation. The speed is very slow for alpha particles because the mass is heavy, whereas the beta particle, the mass is very small. That's why it's fast speeds and speed of light, that is very high speed in the gamma radiation. The ionizing effect is strong in case of alpha particle, but weak for beta and gamma particles. Mostly dangerous all of three particles, and depend how much exposure is happening inside the body, right? Now here I have seen a small pictorial representation. You can see there are 3 different barriers: paper, aluminum, and lead. But when alpha particle is exposed, it it uh, its penetration power is very less. However, the gamma radiation has a highest penetration power. It goes through the paper to aluminum to lead. So what is neutron? This is a new type of fundamental particle which is called the neutral charge, and its name is neutron. The positive charge, the proton and electron has negatively charged. The mass of the neutron is 1.6749 into 10 to the power minus 27 kg. The atomic number is oftenly represented as Z. The number of proton is equivalent to electron. The N is neutron number, and the atomic mass number is designated as A, which is the Z plus N, the total number of proton and neutron. So if anyone asks you what is the neutron number, then you have to calculate the amount of electron or proton number, and you have to subtract the atomic mass number to proton number. You will easily get the amount of neutrons, right? For example, the nucleus of an uranium atom is represented by 235 uranium-92, which means that one uranium atom consists 235 nucleons, which is 92 protons, and rest of 143 are neutrons. Next, the isotope, isobar and isotones. What are the isotopes? Isotopes are variant of popular element with different number of neutrons. For example, the two isotope of uranium 23592 and 23992, right? You will see here that number of proton is same in both of the isotope, and it consists 143 and 147 number of neutrons respectively. The presence of extra neutrons significantly changes the behavior of particular atom. There are two different types of isotopes which may be stable or may be unstable or radioactive. The stable isotopes are one that can exist in free state without breaking down spontaneously. The radioactive isotopes are very unstable, and it can spontaneously decay or break down into a lighter daughter element with emission of the particle alpha, beta and gamma rays. What are the isobars? The isobars are the element have the same number of nucleons, the proton or the neutrons. The series of element with 40 mass number serves as these isobars. So you can see sulfur, the 40, and chlorine 40 atomic mass, the argon 40, and you can see rest of the other element which has the 40 atomic mass number, which is called the isobars. The nucleus of all above mentioned element contains the same number of particles in the nucleus but contain the varying the number of proton or neutrons, right? What are the isotones? Isotones are the atoms that have the same number of neutron number but different number of proton number. For example, sulfur, you can see the same number of neutron number but the proton number is different. So nuclear fusion and fission. Nuclear fission and fusion are the two different concepts. You can see what is happening in the fission reaction. The neutron is basically bombarded into the larger nucleus or the larger element, and after the bombardment it gets unstabilized and it emits the neutron particle or the other kind of fusion products. Whereas the nuclear fusion is basically sum up. The deuterium and tritium, it gets sum up and forms the bigger larger element, and followed by it gets unstabilized and the particle is removed as a energy or the smaller nucleons, right? Here you can see the concept like neutron, when it's bombarded in the uranium 235, it emits into the uranium-236 and followed by other neutron particles. Whereas the nuclear fusion, the deuterium or tritium ion is sum up and it gets from the unstabilized nucleus, and that unstabilized nucleus is basically decays in the radioactive particles. The Isodiapher and Isostar. The Isostar are the molecules or the ion that have the similar shape or often have the similar electronic properties. For example, these are called the Isostar or isoelectric number. The oxygen 2-, fluorine-, neon, sodium, magnesium and aluminum. Whereas the isodiaphers are the atom with different atomic number and mass number but have the same difference between number of neutrons or number of protons. For example, thorium 90-234 and uranium 92-238. The thorium proton number is 90, the neutron number is 144. So the rest of the part is comes out from the neutron particles, right? The uranium and proton number is 92, the neutron number is 146. So these are called the isodiaphers. Next, the radioactive T-half concept, and you can see here with time the concentration of the radioactive elements is decreases half amount, right? 50% and then 25%, like that way. So the concentration is decreases in with half time. So here it has considered as a first order kinetic reaction. That's why it comes out with this way, the logarithmic of concentration, initial concentration by of the final concentration of the product, and K is considered as a rate constant with time. So after solving this equation, it comes out the first order kinetics reaction where T half is equal to 0.693 K. K is the rate constant. And you have to remember this formula because in mathematical derivation, you need to derive this formula, and also for calculation of the half-life, you need to remember this rate constant, right? So at conclusion, radioactive is a nucleon phenomena when the N by P ratio, the neutron to proton ratio greater than 1, then the nucleus gets unstabilized and radioactivity happenings, right? So you have to remember this formula, logarithmic formula, the first order kinetics, and for your mathematical calculation, and you need to remember of these properties of the alpha, beta and gamma particles, right? So these are the brief idea of the radioactive elements. So there are other kind of stuff is also there, so I'll try to cover in my next video. So keep watching. Thanks. If you have any doubt, just let me know, and please do like, share and subscribe.